This is the 4.8 to 4.10 review. Calculators are allowed, and it's number 9. And I'm going to give you a heads up that a lot of people miss this number 9, not because they don't understand the problem, but because they misuse this v equals 6 information. So what I'm going to do, because the calculator is allowed, is I'm going to organize the information so that y1 is going to be my position function, and y2 is going to be my velocity function. So we'll actually want to replace these t's with x's when we put them in our calculator. So y2 is going to be an x cubed plus a 4 sine of x, and y1 will be the position function after we figure out what it is. Now remember that the position is the antiderivative of the velocity function. So if we look here, my velocity function's antiderivative will be the answer to the question, what did I take the derivative of that gave me this value? So this one will be the power rule backwards, which means I'll increase that 3 by a 1, and I'll divide by the new power. Then I'll move through the constant and hit the sign. So what do you take the derivative of that gives you a positive sign? That's a negative cosine of t plus a constant. So in order to nail down the constant, we need to see if there's information given to us about a point on the position curve. And they tell us the particle is at the origin when t is 1. So that means my position is 0 when t is 1. So if I solve for c, I'm going to get 4 cosine of 1 minus 1/4. So now my position function will be this with x's plugged in for my calculator option, plus that c, which I just figured out. So what I want to do now, before I try to answer the question, is I'm going to take a little time to put these functions into the calculator. y1 will be the position, y2 will be the velocity. So I'm going to pause for just a second. Okay, so we're back now. We have the two functions put into the calculator, and I had a little error here. That should have been an x to the 4th over 4, so I fixed it and I have entered it in. So we have y1 as the position, we have y2 as the velocity. The question is, I want to know what is the position at the time when the velocity is 6. So in order to compute the position, I need to know the time that would give me a velocity of 6. To find that, I'm going to go to my calculator on the home screen, and I'm going to solve for when my velocity, which is in y2, equals 6. So I'm solving for when y2 of x equals 6 with respect to x, and I'll hit a diamond enter. Here we have our value, x equals 1.2916. So this is the time at which our velocity was going to be 0. So the question is, what's the position at that time? We have stored the position in the calculator in y1. So we can do y1 of x evaluated at the time we just computed. So we can turn it black and hit enter. And now we will be plugging this value of x into the position curve we've stored in y1. So if we hit enter, we get a 1.504. So we can write on our paper, the position at the time 1.29163 is 1.504825. So I think the answer is 1.505 or 504. You can either truncate or round, your choice. So part B works exactly the same way. We need to know what our velocity is. We need to know what our position is. So we've got our velocity already. That's going to be our y sub 2, or excuse me, our y2 of x. And our y1 of x, we should have x's in them, not t's, sorry. Our y1 of x is going to be the position or the antiderivative of this. So the antiderivative of this, and we're only looking on the right side, will be the log natural of regular x. I don't need the absolute value because I'm only looking on the positive values, minus an x squared over 2, plus the antiderivative of cosine is a sine, plus some constant. So to figure out what the constant is, we were told that the particle's at the origin when time is 3. So that means this position function will be 0 when I plug 3 into the function. So that c will be a 9/2 minus an ln of 3 minus a 3 sine of 3. So I can put this down here as my constant. So I'm going to take a break so I can put these into my y editor, and then I will resume. Okay, so I have put my position function into y1, I have put my velocity function into y2, and if we read the instructions here, it says we are told or want to find the position at the time when velocity is 8. So what we're going to do on the home screen now is we're going to solve for when that velocity function equals 8. So velocity, remember, was stored in y2, so we'll set that equal to 8 and solve. So we have a negative value, another negative, oh, and here's a positive. X equals 1.90657. So we're going to come down here, clear out what's in here, and we want y2 of that number. Now we have an option. I could come up and turn these black and then have to erase everything, or I can just type in the 0.19065713729 Close enough, hit enter, and we get 8. Oops, I plugged it into y2. I should have plugged into y1. We just verified that the velocity is indeed 8 at that time. What we want is the position at that time. So we want to plug that number into y1, and we get a 1.871. So velocity or position at the time 0.190657 equals 1.871.